Hi, my name is Mr. D, and today I want to take a look at using the product rule to find derivatives. So we have find the derivative of the following functions, and we have f of x equals x squared times natural log x, and we have g of x equals radical x times tangent x. For both of these problems, we're going to use the product rule, which states that uv prime is equal to vu prime plus uv prime. And remember, the prime symbol just means find the derivative. So for this problem here, to stay organized, we're going to define u to equal x squared. That's our first function. And we're going to define v to equal natural log x. So the next thing we want to find is u prime. The derivative of u, in this case, if u is equal to x squared, power rule tells us the derivative of x squared is 2x. Whereas here we have v prime is equal to 1 over x. What we're doing is taking the derivative of the natural log. Now we're just going to plug in here to our product rule. So this tells us f prime of x equals, and now we have vu prime is 2x natural log x, we're just multiplying these two, plus, and now we're going to multiply x squared times 1 over x. But if we look at this part here, notice that when we do x squared times 1 over x, that's going to simplify to x. So we could just write this final part here as plus x. And this is going to be the derivative of our first problem here. So if we look at the second example, g of x, this time we're going to define u to equal x to the 1/2. Now just recall x to the 1/2 is how we would express radical x with a rational exponent. And the reason why we want to do this is because when we take the derivative of this, we need to be able to use power rules. So this just allows us to move forward to the next step. And then we're going to define v to equal tangent x. So for the first part, u prime, we're going to use power rule. This is 1/2 times x to the 1/2 minus 1, which is going to give us negative 1/2. And then for the second part, we're going to have v prime equals the derivative of tangent x is secant squared x. So now to close this problem out, we're going to use the product rule once again. This time we're evaluating g prime of x. And this equals vu prime, which is going to be 1/2 x to the negative 1/2 times tangent x, plus, and now we're going to add the product uv prime here, which is x to the 1/2 secant squared x. Okay, to simplify this a bit, let's say we want to express our answer with positive exponents. We're going to write g prime of x equals, and in the numerator we're going to keep tangent x. In the denominator we have 2x to the 1/2. Make that a little bit neater. This is a 1 over 2. And then for the second part here, we're just going to have x to the 1/2 secant squared x. Alright, one extra small detail here. Depending on how your answer key is organized, x to the 1/2 might be switched back to radical x. So this is one acceptable answer, or we could call this radical x, and we could call this radical x as well. Okay, well this is going to conclude this video on using the product rule to find derivatives. Thank you all for watching, and I hope that this was helpful.